Very good morning, all of you, and welcome to the course. As this is the first lecture for the course, I will try and establish overall framework within which we will be conducting this course, irrespective of what is the motivation for coming to this course. There are certain expectations that all of you would have from this course, and I am hoping that this course would, to a large extent, be able to meet those expectations. So what we are going to do as part of today's lecture is to kind of look at the overall course plan and what we intend covering, which also may help some of you to make up your mind about whether to continue with the course or whether take another option. So let me begin today's session. So let me share the content. So, are you able to see my screen?
Yes, sir.
Okay. So, let me once again wish all of you a good morning, a very happy new year, and welcome to this course. As all of you are now aware, it has been scheduled in slot number 3. So we are going to have 3 class sessions, one on Monday from 10:35 to 11:30, another one on Tuesday from 11:35 to 12:30, and then Thursday, that is today, from 8:30 to 9:25. The venue as per the current institute policy is virtual, and as I had mentioned in my post on the Moodle that we will be doing it through the Google Meet platform. So let me begin by introducing the subject itself that we are going to look at as part of this course. So this is kind of a foundation course in relation to space, and that's why it's also connected to some of the fundamentals that are related to the discipline of space. And all of us have great fascination about the space in different forms. And the reasons are not very far to seek that we believe that it contains information relevant for the formation, existence, and continued sustenance of our own planet, because we are part of the same system. In this regard, if you look at a bit of history, astrophysics has been an important space science which has evolved quite some time back, and it employs the principles of physics and chemistry to provide information about nature of space and the objects which are part of the space. Similarly, astronomy, it's a very old natural science and provides information about origin and evolution of celestial objects such as planets, stars, galaxies, primarily based on observed data. And that has brought in an important aspect that we can say is the genesis of the space mechanics as we know today. Because when we talk about observed data, we need instruments for observation. And that is where the issue begins. The issues pertain primarily to the instruments which are terrestrial, which means they are on the surface of the earth. And then no matter how good you design them, they will have a limited reach. All of us are familiar with telescopes which magnify the faraway objects so that they can be observed. There are different kinds of telescopes that people have developed, such as optical telescopes, the radio telescopes, and for different kind of radiations that are present in the atmosphere and space. But then there is always a limitation on the amount and quality of information accessed through such means. And obviously, as your thirst for knowledge is unlimited, you would not like any limitation on the amount of data and the information that you can access. So obviously, at some point, you will feel that no matter how big a telescope that you create, there will always be something that you will miss. In fact, I may mention here that maybe some of you can look at internet to find out about a radio telescope which is I think in operation in Australia, which is supposed to have the surface collection area of equivalent of a square kilometer. But then such facilities cannot be created everywhere. There is another aspect which people have realized, that many Earth-related activities such as communication are also found to be better performed with instruments positioned at higher altitudes. Very common examples are microwave towers for radio communication, telephones, mobile towers. You will generally find that they are all located on elevated places like top of tower, high-rise buildings, small hills, so that they can get a better reach. And this has kind of pushed the idea of space-based objects to essentially serve both terrestrial as well as space exploration needs. So this is the fundamental driver for the space discipline, that you would like to explore the space better. You would like to know more about it with better clarity, and also create better facilities on the ground. Now, in order to serve this, there are certain things that have been done as part of this discipline. And as this is a first course in domain of space, we need to create an overall course plan which provides useful information as well as important perspective on the space, along with methods and procedures that can help us to create such objects. So let me now discuss the plan of the course that we are going to follow. The broad objectives for this course which I have set are that you will probably be able to understand fundamental principles governing ascent mission design, including configuration design of launch vehicles. That is going to be an important element of this course. And this is going to be followed by an exposure to basic concepts of spacecraft orbital mechanics and some ideas about interplanetary travel and the issues involved in that. And the course will also highlight issues concerning the entry or the re-entry missions of reusable launch vehicles, an important element of space technology, and various strategies that address these challenges. And with that set of objectives in mind, let me also give you a little bit of detail about the contents that we are going to cover. So as part of the ascent trajectory or ascent mission, we're going to look at space mission and role of launch vehicles as well as spacecraft. Then we're going to look at some elementary mathematical models, the different kind of motions that ultimately provide the desired performance. We will follow this up with design of rocket through the basic ideas of multi-staging along with their benefits. We'll also bring in certain newer ideas and concepts that are being explored over last decade, such as air-breathing rockets, maybe photonic rockets, and discuss some ideas about their attitude stability. Then we'll move over to orbital mechanics, where we'll first establish the fundamental mathematical principles that help us to understand the orbits and also enable us to generate orbits from different initial conditions and understand them in the geographical context. Then we will move over to operations and maneuvers for the spacecraft and bring in the ideas of launch window, docking, which are important practical aspects of any space mission. We will kind of round off the content with the interplanetary missions and re-entry missions, where we will talk about a non-Keplerian formation, departure and arrival solutions, and then, of course, some basic ideas of re-entry that is an extremely important element of any reusable launch vehicle mission. Following are the books that are fairly useful, but let me also make a mention that by and large, the slides and the lecture material that I'm going to provide will be broadly useful, but you may refer to these for additional problems, some gaps that I may leave in the slides. So let us talk about some related ideas such as prerequisites for this course, because a lot of students do have this question that does this have any prerequisite? So as most of you have already noticed during registration that there are no prerequisites mentioned, so you can register without any restriction. But then any course does require some background preparation, some understanding of basics that are useful in understanding some of the ideas. So I would still say that a good familiarity with basic Newtonian mechanics, mathematical and numerical techniques for solving differential equations, which means some understanding of integral calculus, is definitely desirable. So if you have a reasonable mathematical background, which I'm sure most of you would have, I'm sure the course would not be a problem. Of course, there is a small rider which, even though it is not very critical, some understanding of basic aerodynamics, propulsion, atmosphere, as applied to space vehicles would be useful. Even though I may introduce some of these ideas and also provide some basic understanding, but it would be useful for you to read some of these things just to be able to appreciate some of the decisions or the ideas that are part of the formulations. Let us also talk about evaluation and attendance policies. So what I am showing you here is the overall framework of the evaluations. So there are 5 components, all of them having equal weightage of 20%. So there's going to be one assignment written. There will be a Viva as part of this, and it will require upload on Moodle. There are going to be 2 quizzes, one before the mid-semester and one after the mid-semester. Again, it would be in the written form and would require upload on Moodle. Mid-semester also will have the same character. End semester also will have the same character. And then, as is customary for all of my courses that I conduct, we're going to have regular class tests, which are going to be of multiple choice type questions, will be conducted through Moodle and will be fairly frequent as part of the various class sessions. I'm going to talk a little bit more about it a little later. So this is the overall distribution of the evaluation. Then regarding attendance, well, I do expect that almost all of you would always be part of the online sessions that we are going to conduct. But as there could be some technological issues like communication, connectivity, power, and it may not be possible to join for reasons beyond your control. So I'm not making the attendance mandatory. So obviously no DX grade. I'm not going to take any attendance. And some of you who may have registered for this course as an audit, the requirement is that you must be able to get the minimum passing marks to be eligible for an audit grade, because there is no attendance requirement. You can choose which evaluations you would participate in so that you are able to get the minimum passing marks, and that would give you an audit. It is also useful to understand the overall compensation policy. So for some reason, if you miss the class tests, which are going to be fairly frequent, they will not be compensated. So this is what you need to keep in mind. So if you miss a class test for different reasons, then it is a miss. There will be no compensation for that. However, if you miss a quiz or if you miss a mid-semester, either for medical reason or for other compelling reasons such as long duration internet glitches, power cuts, then these will be compensated as considered appropriate, and those policies will be announced as and when such requirements come up, but they will be compensated in an appropriate manner. Of course, if you miss the end semester, then this will be as per the overall rule of the institute. And there will be no specific policy as far as the course is concerned. Whatever institute decides with regard to end semester will be implemented. So please keep these facts in mind. Now, what is the delivery mechanism that we are talking about? So the course will be mainly conducted through Moodle. What I mean by that is the course material will be uploaded only on the Moodle. And as most of you would be automatically registered through ASC on the Moodle, you would have access to all the course material which is going to be posted, including any announcements regarding the examinations and other related material. The way it is going to work is that lecture slides pertaining to each week will be uploaded on Moodle at the start of the week. What I mean by that is that in a particular week we have 3 classes. So the lecture material corresponding to those 3 classes will become available latest by Sunday of the week. The idea is that you would be able to get time to review these slides and lecture material that we are going to be discussing during the class sessions. So the way we are going to configure class sessions will be that we will discuss these lecture material, clear the doubts, solve problems, and also use the same time slot for conducting the class tests. So all of this we will try to pack in the time that is given to us, that is roughly about 55 minutes in each of those. And for that reason, if you recall, I had mentioned in the beginning that we would like to start by 8:30 so that we don't miss time, because we are going to have multiple components that we would have to adjust within that 55 minutes. And also for that reason, I would also request all of you to join the class between 8:25 and 8:30 on Thursday as today, between 10:35 and 10:30 and 10:35 on Monday, and 11:30 and 11:35 on Tuesday, so that we can begin the class on time. As I have already mentioned, I'll be using Google Meet as the VC platform for the class hours, and whose recording would be available through link posted on the Moodle. Please note that this link will be accessible only through your LDAP ID. So you must log in with LDAP ID to access the recording link. And as has been the institute policy in the last semester, for all such online classes, all exams, even including the class tests, will be proctored as per the standard guidelines of any proctored examination. I think with that, I have kind of come to the end of what I wanted to tell all of you in this particular introductory class. So then with that, I think we will close today's session. So let me stop the recording.